I am a prosthetics user. What I want that to mean is that the functions of my missing organic limbs are almost completely replaced with bionic appliances at the absolute cutting edge that modern innovations and leading minds in medicine, engineering, and design can offer. But what it actually means is that I have what humans currently offer to a market where the only customers are amputees. It's worth keeping that in the back of your mind, that the prosthetics I can access right now are off-the-shelf commercial products, and therefore designed with all the associated limitations like profitability and planned obsolescence. Because they're designed and sold to make money, they of course have to be useful. And useful they are. Quite useful, for many. But they are nowhere near the organic limbs they seek to replace. You can use the same organic leg for countless tasks: running, walking, jumping, kicking, sitting, balancing, to name a few. At the moment, a prosthetic leg focuses not on the biomimicry of the limb itself, but on mimicking the output of that limb, one function at a time. So let's say someone wants to move forward, very, very fast. We give them a running leg, using big carbon springs instead of feet. Often, these prosthetics can actually exceed the performance of an organic human body. What's cool is that carbon blades are not only body-powered, initially, but in a way they are also powered by falling, turning downwards energy into forward energy, due to the geometry of the spring. I have worn one myself, and stepping on it felt as though someone shoved me from behind. It's incredible. Extra muscular activity is needed to maintain that in normal lower legs, but you get a propulsion boost from the right running blade. An athlete's challenge is moving these fixed blades rapidly back to the most advantageous position. This is still an incredible task of endurance and sees the VO2 max, or in other words, maximal oxygen consumption, as well as breathing and energy use, be as high as the world's best able-bodied athletes. But the story changes dramatically if you want to do almost anything else wearing those blades. If you get an athlete wearing 2 of these blades to go bouldering or climb a tree, in some cases even walk down stairs forwards, or walk down an incline, without muscles, heels and ankles, dynamic joints and pressure and position sensors of the flesh, they will suffer the inadequacy of the design for this task. Simply put, increasing or providing alternative abilities for the body currently comes with drawbacks. When all added up, we do not have the physical technology to outperform every feature of the human body. What would be the tipping point? What would be the average or net benefit that tips societal uptake of bionic replacements? Would you take 130% of the running ability of the world's best athlete if it meant you couldn't walk along a beach without sinking and getting stuck? I can't tell you how much mental energy it takes to walk across wet, shiny shopping mall floors without having an ankle. There is a market for body enhancement. That is evident by the health hacks and diet trends that you see everywhere on social media. However, whether people want to take real action upon their own health or just spend dollars to have an appearance of health is another question. In a world of curated existence, maybe we'll have ever-expanding peacocking of people upgrading limbs beyond their means and necessity. It is a human trait to do so, and one I find very understandable. One of my favorite arm parts for functionality is the one I consider least attractive, and so I tend not to post images of myself wearing that device. I wish it looked cooler. It's a fact of biological life that real improvements to your physical health and abilities take time, effort, and consistency. By and large, the reason most of us are not elite athletes is that we don't rate the cost-benefit of that intense effort as worthwhile. Augmentation of the mind's abilities is traditionally done by consistent training and practicing skills until they are perfect. But a much more attractive proposition would be downloading skills from the matrix on a Neuralink connection. So, It appears to me that the allure of being a technical mechanical human being stems from the immediate or rapid expansion of abilities with minimal effort. Whether we use our expanded abilities once we have them is another question. When you are shopping for body parts off the shelf, you are also entirely dependent on whether you as an individual fit into the expected mold, your body's size and muscle signals, to be able to make use of the hardware and control systems. Though technologies like pattern recognition are making this simpler for some people. What I find hard to break down in my mind is the transition, or the jump, between developing these technologies for disabled people and jump to the able-bodied person. As someone who has had multiple surgeries, I have direct experience of the fact that any working material you have remaining that's originally connected to your central nervous system and brain is incredibly valuable. This is a set of equipment which has been in A and B and C and D tested, and honestly, there aren't enough letters in the alphabet, and developed for more than 360 million years. And upright apes have refined bipedal locomotion for 4 to 7 million years. That's a little bit more development time than for the bionic tech developed by small groups of humans in the 21st century. Not to discount their work, they are making progress, but they are children's drawings of limbs in comparison to the detail of biology. Able-bodied people have very advanced organic equipment factory installed. I cannot see a point where it would be a fair or equitable trade to electively replace it with alternative abilities. The intervention of virtual prototyping by machine learning, AI systems, and iterating hardware for the real world may see this happen, but I doubt it will be for hundreds, or up to thousands of years. With carbon blades, the strength, speed, and endurance of the body is in question, but the nervous system is not. And damaged, it's the most valuable part of you. The fidelity of the link to the central nervous system and brain is too usable to throw away. Non-destructive brain-computer interface are the next step. Accessing and supplementing the experience of the able body with neural decoding and response. I can picture a world of connected equipment including exoskeletons, and mind as controller first-person view remote robotics, especially for work in polluted cities. Everything else is getting ready for excellent technology. When I lost limbs 8 years ago, Boston Dynamics was still using fossil fuel to power their human-scale robots. But they're now using modern, advanced batteries, the same battery tech that now drives lighter and more precise prosthetic hands. Hands with better microelectronics and motors, able to articulate and behave closer and closer to an organic hand. But getting natural, intuitive, and 100% reliable control of limbs is the missing piece of the puzzle and sorely needed. Ironically, I don't believe that the innovation will come from prosthetics, but it will come from the work into brain-computer interface for able-bodied people. My personal view is that what humans have is already really good. Our biological machinery is resilient to so much that could see a robot corroded and in repair for weeks. Technology is going to try and keep us fresher for longer, aiming to preserve us past our expiry date. But it's a big jump to go mechanical. Things like gene editing may seem more futuristic, but in my opinion, are more realistic. At the point in people's lives where they'd seriously consider replacing their organic parts with mechanisms, they are probably not going to be resilient to the stress that change would place on them. Perhaps with brain-computer interface, you may better support your aging body with external robots instead. Brain-computer interface needs testers, though. No doubt it will be licensed first in those with things like spinal cord conditions, and later amputees. At least for these people who have experienced chronic disease and illness, we might be able to have some fun exploring the hardware of super-powered arms, testing the limits of what a human body can locally consist of. After my accident, and losing 2 limbs, it was disheartening to realize the majority of the most exciting ideas about bionics were inaccessible today. What is available outside and inside of research is incredibly clumsy in style, incredibly financially limiting. The ticket price of regaining moderate bionic function can be on the scale of a premium vehicle to the price of a house. Some of you might be familiar with the social model of disability. It refers to the fact that disabled people are not disabled by their minds and bodies, but by the society and world in which we all live. At the moment, society is telling me that accessing the best current prosthetics should be considered a luxury, attainable only if I can exchange a high 5 to 6-figure sum for the privilege. And because those sales do happen, there seems to be a paucity of incentive to make the prices accessible, or to turn research towards the profoundly innovative rather than the solidly profitable. The UK is historically risk-averse in this area, but it will be the high-risk investment strategy in brain-computer interface, prosthetics, and robotics that will result in the most pronounced changes to the quality of life. These will also be the most exciting applications for the industries that will eventually experience a high return on that investment.